Hello, this session is the second part of the WEAP scenarios video tutorial. In the previous session, we saw how scenarios are managed in WEAP, defined the reference scenario, and explored some results. Now we will create an additional scenario and compare the results between scenarios. We will also see WEAP features for managing results, such as saving a chart as a favorite, exporting results to Excel, and viewing the results dynamically on the WEAP schematic. This video tutorial covers some sections of the scenarios and data, results, and format chapters of the WEAP tutorial. Remember that setting up current accounts is the first step for implementing scenarios in WEAP. The scenarios are created first from current accounts. After defining current accounts and reference scenario, you can add more scenarios to answer the what if type of questions. In this exercise, we will add the scenario what if the growth rate is no longer 2.2% but 5%. We will create the higher population growth rate scenario and compare the results with the reference scenario. Go to WEAP. Create a new scenario called higher population growth rate. Go to the data view and access the manage scenarios at the top. Click on add and call it higher population growth rate. Remember that it is important to describe the scenario to document the changes made between scenarios. Add the description population growth rate equal 5% and same irrigation technology improvement. Before closing and modifying variables, it is important to verify the scenario on which the new scenario is based. Check the scenario 3. Reference and higher population growth rate are based on current accounts. Remember that when you create a scenario by default, the scenario inherits the expressions from the scenario on which it is based. In the previous video, we changed the key assumption expressions of the unit irrigation water needs and estimated growth rate for setting a scenario where the growth rate was 2.2%. Besides, there was a gradual reduction in the annual water use rate in the agriculture node due to an improvement in the irrigation technology used. We also used the growth function in the annual activity level variable for the big city demand to project the population. The rest of the expressions in the reference scenario are the same as those added in current accounts because we have not made any other changes. What we want to do now is only to change the population growth rate. We want a scenario that represents the same conditions as the reference scenario, but evaluates the impact of a higher population growth rate. If we leave the higher population growth rate scenario based on current accounts, it will inherit the current accounts expressions. Because we want to maintain the changes that we made on the reference scenario, we need to change the scenario from which the higher population growth rate scenario is based. The higher population growth rate scenario must be based on the reference scenario. We can see that the three changes. The higher population growth rate scenario depends on the reference scenario, and the reference scenario depends on the current accounts year. Setting up a scenario depends on the modeling interests. The interest is to model what will happen if the population growth rate is 5% and not 2.2%, and the rest of the conditions remained the same. Therefore, the higher population growth rate scenario is equal to the reference scenario, except for the growth rate value. Click on Close. Now we are going to change the population growth rate in the new scenario. Remember that we have a key assumption to control the population growth rate. Go to the estimated growth rate key assumption and modify the value. Change it to 5%. Because this value is different from the expression on the scenario on which it depends, it is shown in red. If we delete this expression, it appears a value of 2.2%, which is the expression of reference. If we modify it, it is shown in red. Change the scenario where we are entering data at the top. Select Reference. We see that the rate is 2.2% and it is in red. This is because the scenario on which it is based, which is current accounts, the expression is 1.75%. For example, if we go to the big city annual activity level variable, the expression is shown in red for the reference scenario. However, if we select the higher population growth rate scenario at the top, the expression is not shown in red because we are maintaining the expression from the reference scenario. If the expression is different from the one in the scenario on which that scenario is based, it is shown in red. We already have two scenarios. The reference scenario with the modifications on the unit irrigation water needs and estimated growth rate key assumptions, and on the annual activity level variable for the big city node. We also have the higher population growth rate scenario. We changed the population growth rate value for that scenario. Go to Results. Yes, we want to recalculate. Before proceeding to explore the results, save this version. Go to Area, Save Version, and name it with Scenarios. Click on OK. Go to Demand, Water Demand. Select Annual Total to aggregate the results. Select Big City under the branch options. It is essential to check the units of the results. It is million cubic meters. On the graph, we can see a large difference between the water demand among the scenarios if the population growth rate increases. If the rate is 2.2%, the water demand would be around 363 million cubic meters. And if the rate is 5%, the water demand will be around 544 million cubic meters in the year 2015. Check the coverage. Go to Demand Coverage. We can also see on this chart the impact of the population growth rate. The scenario with a higher population growth rate will have lower coverage. Go now to Demand Unmet Demand. The unmet demand results show the volume that would be needed to meet 100% demand. For the higher population growth rate scenario in 2015, we will need around 132 million cubic meters with a growth rate of 5%, while with a rate of 2.2%, we will need around 40 million cubic meters. WEAP has many features to manage the results. In the menu on the right, you can change the chart type, colors, add labels, and change the axis. Another WEAP functionality is to save graphs as favorites. Sometimes a graph is customized for a particular result by changing the axis, color, units, or dates, and it will be convenient to be able to access the same graph again and not lose the changes. This can be done by saving the chart as a favorite chart. Go to Favorites at the top and select Save Chart as Favorite. A name must be assigned, and a description of the chart can be added. Name this chart Unmet Demand for Big City. Click on OK. We can continue exploring the results. Go to Supply and Resources, River, Streamflow. We see a continuous line because we are seeing the streamflow as volume, million cubic meters, and the total annual option is selected. This will be the annual volume at the headflow of main river. Display the results of the streamflow available downstream of the first withdrawal node. We see that the available streamflow at that point is declining because the big city water demand increases year by year. If we want to check the graph we saved as favorite, we need to go to Favorites, Unmet Demand for Big City. The saved chart is shown. Saving favorite charts is a useful option to access results more easily and directly. You can also change the chart type by selecting bars or lines. You can change the colors as well. You can also modify if the y-axis starts from 0. See the graph in 3D, change the axis logarithmic scale, active the grid, add tags. If we go to the Table tab, we see the time series on the graph. We can export the data table to Excel by clicking on the Excel icon on the right menu. It is possible to include basic statistics by clicking on the Statistics button on the right. If you export the data to Excel, it will be exported with all the information. Before exporting WEAP results, we must select which variable we want to export, the units, the element, and the scenarios. We can select annual total or monthly average and then export the aggregated data. In the Chart tab, we see a graph of the data. In the Table tab, we see the values. In the Map tab, we can see the results dynamically on the WEAP schematic. Results are shown on the map as numeric labels and varying the line thickness or node size. On the toolbar on the right, you can turn on or off the numeric labels and change the line thickness or node size. You may increase or decrease the precision for the numeric labels using the buttons on the toolbar on the right. This button will copy the map with results to the Windows clipboard. There is a slider at the bottom to see how the results vary over time. For example, in August 2000, the unmet demand is 8.44 million cubic meters for the big city and 35.83 million cubic meters for agriculture. You can continue exploring the results in the Chart, Table, and Map tabs.